Good morning all. Today I'm playing with a thermal imaging camera. It's the Xintest HT-02 handheld thermal imaging camera. Now this device has been kindly supplied by Banggood, so thanks very much to Banggood. And for more information on that arrangement, please see the description. So let's just have a look at the box this came in for a moment. It's mostly in Chinese, but you can see minus 20 degrees C to plus 300 degrees C and plus or minus 2% there. Inside there's a pouch which has the camera in it. There's also a strap with some carabiner type connectors, and there's an instruction manual. The instruction manual is 100% Chinese, not a single word of English in here, so I've had to hover my camera running the Google Translate app over some of this to try and work out what it's saying, and I think I've got the gist of it. Now what I didn't want to do with this was my usual thing of blundering through, learning as I go along, so I've actually had a couple of hours playing with this thing, and I think I understand it reasonably well, and I'm going to be completely open about what I like about it and what I dislike about it. Right, first things first, let's look at the battery compartment. Here it is. It takes 4 AAs. Now the question is, alkalines or rechargeables? And this one's quite a difficult decision, because with alkalines, the battery monitoring, either hardware or software, whichever it is accurate, and it uses all the energy in those alkalines, but it does use it quite quickly. With rechargeables, the battery monitoring is inaccurate. Now I'm going to use rechargeables because I just can't bear the thought of running down a set of alkalines. That's just a costly way to do things. So I'm going to use these loops. They fit in there very tight. You might want to put a bit of ribbon in there because it's quite hard to get them back out. Okay, so that's the batteries inserted. Let's switch it on. So press and hold the left menu button to switch on. It says thermal imager, and it comes on. And what have we got? Well, at the moment we've got a mixed optical image and thermal heat map. Now we need something that's going to get warm and or cold, so I'm going to use a Peltier element, but just before I do that, look at the battery symbol. It's showing that the batteries, those rechargeables, are only about a third charged, and the problem is it doesn't use all the energy in them. When this thing shuts down and says no more power, the batteries were actually at about 1.35 volts, which for rechargeables is high. Right, I've rigged up the thermal imaging camera on a tripod. It does wobble around a bit, but that might not be a bad thing. Now you can see at the moment that it's showing a live image of the desk. And if I put my hand under there, you can also see that we're getting superimposed on top a heat map. So the center of my hand is hot and my fingers are pretty cold. So what I thought I'd do is use one of these Peltier elements, and then I can flip it over to show the hot and the cold side. I've got a heat sink here because that makes the hot side get hotter and the cold side get colder. So let's connect that up with 3 volts. So there we are, 3 volts, or 2.4 volts actually that is. Now is this the hot side or the cold side? Okay, that's the cold side, and you can see a cool blue-black area showing the cold side of the Peltier. And if I flip that over, once the Peltier has a chance to readjust its temperature, you can see a warm area on the warm side. These are the white and yellow colors, and then the area around is ambient. Now you may have noticed something here already. There is a misalignment of the thermal map with the optical map, and that's just a parallax error. That's not a fault with the thermal imaging camera. That's the fact that the thermal imager is at the top and the camera's a bit further down. So you just have to get used to the fact that the thermal map may not sit exactly in line with the visual map because of that parallax. Let's have a quick look at the front of the camera. So at the top we've got the thermal imaging camera, and you can see the lens there, which is likely to be made of something like germanium. It's not made of glass, because glass is not infrared transmissive, not at these frequencies anyway. The next hole down, the middle hole, is the regular optical camera. It's just got what looks like a standard sort of mobile phone camera element in there. And the one at the bottom is an LED, which you can use to light your work. If you hold the trigger, the LED comes on. Hold it again and it goes off. So the reason for the misalignment between the thermal map and the visual map is because you've got two lenses here. It's a bit like the old twin lens cameras. Now, one thing you can do with these two images is you can change their relative intensities. So we can press this button to go left. That means that we're left with just the optical image. Press it to go right. That means we're mixing the optical image and the thermal image, and we can carry on going right and just get the thermal image. Now notice that when we've got the optical and the thermal image, if I move it, the thermal image has a lag because it takes a while for the thermal sensor to actually see the thermal changes. So there's a lag between the two images. That's not a fault, that's normal. Okay, what can we see on the display? Well, battery level, emissivity is currently set to 0.95. That is adjustable. The temperature of the target point, which is right in the middle of the screen, you can't see it at the moment because it's white, is 42.2. Let's just check the Peltier. Yeah, that feels like that's quite hot, but not as hot as a central heating radiator, so that would be about right. The min and max temperatures are 23.5, so that's ambient. That's kind of the background, probably on my cutting mat. Max temperature is 42, so yes, that's the central point there. And you can see that currently I'm using the color array, or the color palette, which runs black, blue, red, yellow, white. Right, let's just reduce the optical image so that we can look mainly at the thermal image. Now at the moment, black is representing the cooler areas, which is ambient, so that's about 24 degrees. White represents the high temperature area, that's the hot Peltier element, and that's 42 degrees. Now if I flip that over, remember ambient is about 23, currently represented by black. Well, now of course this side of the Peltier is going to start getting cool, so ambient, which is showing here as 29, that's because this heatsink's quite warm, is now represented by white, and black is representing the extreme of temperature, which is currently 14 and will probably fall further. So the point is this palette is constantly changing. The meaning of the colors constantly moves around. Black, 13 degrees, white, 30. Flip it over. Black, 23 degrees or 24, white is now 38. So the point is this color palette is not fixed, it's continuously varying, and it would be nice if in the menu options you had the ability to fix the colors to certain temperatures. You don't, it's fully auto ranging. Now here's another of my gripes. The optical image is color, and so when you merge on top of it a sort of desaturated thermal image, you can have a fully saturated thermal image if that's all you're looking at, but when you mix them you get a desaturated thermal image. The colors in the color image get mixed up with the colors in the thermal image. So what you really want to do here is turn the optical image black and white. Now I've got some fairly stark colors here, a white Peltier element and a black heatsink. But there's nowhere in the menu to set the optical image black and white. You can't do it. It's always in color. Right, now let's get some numbers. The LCD here is 240 by 320, I believe it is. Let me just check that. Right, it doesn't actually say, but I'm pretty sure it's a 240 by 320 LCD. The optical image uses about 240 pixels square in the middle of that LCD. Now if we flip to the thermal imaging map, that looks very fuzzy. Well, the reason it's fuzzy is because the thermal imager has a resolution of just 60 by 60 pixels. It's very, very low resolution, but rather than show it all pixelated, they've decided to blur it or smooth it, so it does look quite out of focus, but it's simply because it's very low resolution. Right, let's say I'm happy with this image. I want to take a picture of it. I simply pull the trigger and it says store photos, yes or no. Now it'd be great, wouldn't it, if you just pull the trigger again to store a photo, but no, that's the no option. So store photos, yes or no. You now have to press this left button to actually store that photo. That's now stored and it's gone on to an SD card, which is in the top of the unit. I'll show that in a moment. If you do store photos, yes or no, and press the right hand button, it takes the no option. So here on the top of the camera, there's a little flap, and there is a micro, I think it is, micro SD card. They supply a 4 gig micro SD card, which is probably one of the smallest you can get now. And it's massively bigger than you could ever hope to use in this thermal imaging camera. Now I say that because if you look at the stored images, press menu to go into the menu, and I want to look at the stored images. There they are, select, and there are the images. You don't get any thumbnails. They're just image 1 BMP, image 2 BMP, all the way down to the one I took last, which is image 20 BMP. Let's select that. And yes, you can look at image 20 BMP. It's a pure copy of the liquid crystal display. So I think that was the battery level at the point where I took this picture. That was the palette. This was the date and time. These are all the numbers. This was the target temperature, and these are the min and max temperatures. Now, if I go back, we just get that list of images again. So if you have more than a few images in here, it becomes just unnavigable. You just can't find your way around. You don't know which image is which. It doesn't also give date and times actually on these thumbnails. That would help a bit. Okay, other things in the menu, you can set the brightness of the screen. 10% is more than adequate. So it goes up to 90, I think, but that is extremely bright, so you don't really need that. Those are the images stored. That's the time. I think that's ambient temperature. You can turn on and off some little markers which mark the maximum and minimum temperature. So I'll just do that actually. Let's change that to on. You can change the emissivity. We'll talk about that in a minute. You can change the palette. Now there are 5. Black to white through blue, red, yellow. We've got blue to white, it would appear, through purple, green, yellow and red. We've got purple to white, which I think is a bit strange because black to white just makes more sense to me. That's through blue, red, yellow. Not a huge amount of variety there really. And then we've got simply black through white and the inverse of that, white through black. Now I've been finding this one the best. Black at one end, white at the other, with a few colours in between. Right, next thing is, let's switch that off. No, let's switch that on because I now think I've picked the wrong one. Yeah, select that. This is the capacity of the installed card. I think that's just informational. Yes, it is. BG temperature. I'm not entirely sure what that is. It just says in the manual if you have problems with your imaging, change it. It goes between 0 and 36. That's one of the things I haven't really worked out. There isn't a huge amount of stuff in the menu system. Now this Peltier cold side to me feels a lot colder than what it's showing of about 18 degrees. So maybe I've got the emissivity for this ceramic material wrong. E.95 perhaps is not right. I'm going to look up what this tech element is made of and try and set the emissivity correctly for that substance. Right, this here says that the thermoelectric cooler uses 2 alumina ceramic plates, so let's look that up. Right, I've typed in alumina ceramic and that would appear to be aluminium oxide, Al2O3, so now I need the emissivity of Al2O3. Well, now I'm looking at a table of emissivity values and I've got ceramic here, white Al2O3, but this is quoting it at 200 Fahrenheit, 93 degrees Celsius, and it's 0.90. So I'm not quite sure why those temperatures are so high. But you can see from this table that emissivity does vary a lot, because here we have aluminium unoxidized at 25 degrees Celsius, 0.02 emissivity. So it's currently reading a low for the Peltier element of 16.2. Let's change the emissivity. That's the E symbol, isn't it? To 0.90 it was. Okay, that's it. So emissivity is now 0.90. Oh, well, that doesn't appear to have changed anything. Minimum 16.2. And now an emissivity of 0.1, and that's still reading 15 point something, but the maximum temperature has massively shot up to 300 degrees, which it clearly isn't because I can touch that heatsink. So emissivity appears to affect the higher temperatures more than the lower temperatures. Okay, let's try this again with this flipped over. So we're reading the hot side of the Peltier element. So let's just give that a moment to settle. Okay, the hot side at that emissivity rating is showing 285 degrees C, which it clearly isn't. So yeah, that does seem to affect the hot side more than the cold side. Let's do a hot side reading at emissivity 0.9, which was the emissivity for aluminium oxide. Right, I've set it to 0.9. Now that's reading 280 degrees, but I figure that will change gradually. That should drop down now with an emissivity of 0.9. So let's just give that a while to do it. Yes, that's dropping down. So ambient, the background black, is 21 degrees. And the hot point on here is now reading 42, which it is about. That's quite hot, but not burning hot. So yes, the emissivity does seem to affect the higher reading, not so much the lower reading. Now you can see that I've switched on the high and low temperature markers. So the low temperature is 19.3. That's being indicated by that marker up there. The high temperature, because it's a white marker, should be a black marker really, or whatever the palette you're using is in this white area somewhere. So let me just change that palette. Right, the only colour palette I could find that would effectively show the hot marker was the inverse black and white one. So now the cold marker is up here in the white area somewhere, white being cold. The hot marker is moving around in the black area. The black is now warm. Right, let's try another palette. Let's try the one with the most colours. So I'll come down to palette, select, and then go up to, now which one was it? Yes, I think that one has the biggest range of colours. I think that's the rainbow palette, so select that, come out, and there's the rainbow palette of colours. Now, it looks like cold is not black. It looks like it starts at blue and then goes purple, bluish, greenish, yellow, red, and then actually white for the hottest temperatures on that palette. So does this palette work for you? Blue, cold, and red with white highlights for warm. What about the next one? This one, black is cold with red, yellow, and white as the hottest. I think that one works best for me. And this one's just weird. It looks on here, you can't see it very well on the camera, but it looks like it goes purple, blue, purple, red, yellow, white. Why would you go purple, blue, purple? Well, let's select that and see what it looks like. And yeah, it kind of does go purple, blue, and then a different shade of purple. Maybe these are two different purples, but that's just confusing. Purple, blue, purple, red, yellow, white. No, I don't like that one at all. So to me, this Peltier surface feels quite cold, but no, the camera never lies. There's the minimum temperature marker, and it's saying 14.5. Right, it would be pretty unforgivable if I didn't look at an electronic board. So here's a power supply. Let's put it in front of the camera and switch to the thermal image. And there's not a lot to see there. I think that heat is the display just starting to warm up. So let's switch back to normal. No, that's not normal view. That's normal view. And I'm going to put one of these lamps on there for a while to get this thing warmed up. And then we'll take a look at the circuit board on the thermal imager. Right, that lamp's at 12 volts and it's drawing just under 3 amps. That power supply is squealing a bit. But let's see if we're starting to get some heat information. Let's go backwards so I can get the full thermal map. Okay, well, I mean, you can see that the bulb itself is hot. But if I take that out of shot, something's getting quite warm down this end. Let's get in a bit closer. Right, let's switch between thermal view and regular view and try and identify what it is. Unfortunately, I haven't got enough light. Let's take that bulb. Actually, let's just switch that off because then the camera won't be bleached out. Right, thermal view, there's something hot there. I can't quite make out what that is. I think it's that, which is a HT-02 device. Now you've got to factor in parallax, so a bit more thermal image. Yes, I think it's that HT-02 device which has got warm. The inductor's clearly got warm. The lamp there is obviously warm. If that'll come off, yeah. I can get rid of the lamp and just look at the electronics. So yes, I think you can identify the areas which are warm. The inductor there. Is that the connector or the capacitors? Capacitors shouldn't really be warm, but maybe they just got warm because of the light radiating onto them, and they are black coated, so perhaps that's why they got warm. Let's give a bit more thermal map. And I think this area, let's come up to here. This area down here I think is the display. But it looks to me like one of the inductors gets warm. This one, not so much the one at the top here. And that HT-02 device is getting warm. Temperatures, 37.7 is the highest temperature. Can't see the high temperature marker, unfortunately, but I think it's either there or there. The high temperature marker really should be black, shouldn't it? On the back of the board, there's quite a lot of warmth in this bottom area here. Let me just switch off the thermal map. And that's underneath the sticker there. Let's just get the camera out of the way for the moment. Well, actually, that was this stuff under this display here. So if I take the display off, it's just these components here. I'm not entirely sure what they are. But yeah, they're getting warm. Let's take a look at them under the thermal imaging camera. Of course, the temperature it's all cooling down now, but yeah, there is some warmth there. Min and max 18 to 27. Let's come back to live image. There's just some general warmth on the board area around here. Interesting. So that was a little review of the Xintest HT-02 thermal imaging camera. I mean, clearly a very useful device. Is that thing still warm? Yes, there's still a bit of warmth on there. But these things aren't cheap. This is about currently $300 US on Banggood's website. That's just under £250. And it's not perfect. I mean, for me, the power management, the battery thing, is not ideal. This is getting dangerously low. I think that might be ready to shut itself off. And these batteries are no way discharged yet. The lack of the ability to be able to fix temperatures to different colors, I think, is a real shame. There's a fairly limited range of color palettes. There's only one really that I find works for me. And the lack of an ability to turn the optical image black and white is also a real problem, because generally speaking, the optical image is just for alignment. You just want to know what's causing that bit of heat. So black and white optical image is perfectly usable, but you can't do it. You can only have color. But it is a useful thing. I mean, I can tell you, you can't see from this power supply how warm it is, but with the thermal imaging camera, if we go to that hot spot there, we can see that that's at about 40 degrees, whereas the coldest parts of the power supply are at about 20 degrees. That's assuming I've got my emissivity number correct. And it's just switched itself off because it thinks that the batteries are depleted. There it goes. Low power, 5, 4, 3, 2, 1, and off. Let's take a look at those battery voltages. And they are 1.34, 1.34, 1.33, 1.34. Those batteries have still got lots of charge in them. So no longer on this channel will I be saying, oh, it's quite warm, but it's not that warm. Now I can do proper temperature measurements. Cheerio.